Roadrunners from the University of Texas at San Antonio, and we're excited to compete in the 2026 University Rover Challenge. And this is our new rover, Coyote.
My team and I are responsible for designing the chassis, the suspension system, the drivetrain, and the wheels. Our wheels are 3D printed and are based off an existing design that we modified to fit our rover. Wheels are 6 inches in diameter and they're very wide to allow for stability while driving through rough terrain. Our drivetrain uses timing belts that allow for smooth operation and accurate positioning. Timing belts are 5mm pitch, which allow for high torque while operating at low speeds. We have also 3D printed our own custom pulleys to drive the timing belts. Our chassis is very wide and low to the ground for increased stability. And our suspension system uses shock absorbers to allow for robust support to the chassis. Our shock absorbers use both spring and viscous suspension to control both positioning and velocity. Our chassis is able to hold both our arm, our science module, as well as the circuit boards that control them.
These arms, the current size will be around 0.25 meter by 0.25 meters by 0.5 meters. The material of the arm mostly consisting of aluminum extrusion, varies on the size, either 15 by 15 or 40 by 20. We also utilizing a lot of filament. Right now, will be high temperature POA, or they was mostly carbon fiber, nylon, PA12. 3 degree of freedom, 3 DOF. Each of DOF represented by a joint. The first joint will be resolving in the rotation z-axis of the arms. The second joint will hosting the famous cycle gear system that will be carrying most of the weight of the lifting of the arm. The third one of the joints will be carrying the eyes of the arm. Also, the interaction module would be also known as the gripper. The gripper can be removed and add a science module mission in which from picking up material interacting with surfaces mission, it can now obtaining and collecting data samples such as dirt sample and analyzing it. The mass of the arm is around 5 kilograms. This arm can be hold for now 3 kilograms, but the actual one will be holding at least 10 kilograms or above thanks to the cycle gear. And this arm can also interacting with surfacing mission.
The auto team mainly works on tail control, navigation tracking, autonomous systems, and camera vision. For the tele-up, we collaborate with the arm rover team to make sure that their controls to their liking when they are controlling the rover or the arm. We use a radio controller with the Ghost protocol to send data to an ESP because the ESP controls motors and sends data to the Raspberry Pi to create a local cost map so they can create an optimized path to go from point A to point B. Attached to the rover is a camera that uses the YOLO network to capture the Uruku markers when they're far away, and while they're up close, we use a ROS2 package to track the markers.
The science module operates as a fully automated laboratory system on board the rover. It utilizes epifluorescent microscopy techniques and a neural network to provide optimal life detection. The sample will be collected via an augmented auger bit that will gather soil for processing. Once within the module, the automated pipette system will prepare a 1 in 1,000 dilution. This reduces noise within the field of vision of the microscope. The automated pipette system will also be tasked with prepping a slide for observation, including the automated pipette system also tasked with preparing the sample for observation under the microscope on the slide. The slide will contain a portion of our diluted soil sample and a portion of our diluted dye stock. For the purpose of this mission, we have decided to use thiazole green in 10,000 times concentration, diluted to reduce the visual noise and background staining. The dye binds to DNA, providing a visual marker for any light found within the sample. Images of the slide will be taken using both blue and standard microscope lighting. The neural network we have designed provides microstructural analysis further proving any life we found within the sample.